students, we will be talking today about water pollution, particularly with reference to mining industry. So, water pollution, what is water pollution basically? The pure water does not have any chemical dissolved, nor it has got any gas dissolved, nor it has got any turbid solid suspended in that, nor it has got any other suspended particles which are settled in the water, or under turbulent velocity it is suspending in water. That means, if these things are there in water due to mining operations, and particularly to such chemicals which are dissolved in water and are going to cause harms to the human being in one or other way. Why I am saying one or other way means the water is also, it is water is consumed by the human being. So, if it is harmful to the health of the people directly, then it is dangerous, it is harmful, you can say it is polluted. Or else if it is polluting the fields, the paddy fields, if it is causing any other sorts of problem to the human beings living around, then the water is called polluted. Unwanted elements, if it is there in the form of gas or solid or any dissolved chemical, or the gaseous if the gas unwanted gases have got dissolved, which has changed the quality of water to either acidic or basic, highly acidic or highly basic, then it is called polluted. So, what are the types of pollutions? See, as I said in my statements, accordingly the first type of pollution is solid suspension. There are two kinds of it. One is the turbid water, that means the water is partially you can say opaque, it is not clear, you cannot see the light clearly from one end to other end of the water column if it is inside a glass vessel. And then there are some insoluble particles which are suspending in the water, and which is clearly obstructing the light from one side to other if you want to see through the water. So, it is totally making the water opaque. If it is suspended, it will not allow the light to pass, or a very feeble light will be coming to your eyes from other side through the water. Then next is chemicals dissolved. It is either from earth, which are the soluble particles like sodium chloride, you can say, or sodium bicarbonates, you can say. Then there are some gases available in the mining atmosphere. Those gases get dissolved in water and changes the pH value of water either to form acid or to form basicity. Then there is another unseen water pollution, lowering of water ground. Particularly in mining area, when excavation is made, the water has the tendency, the groundwater has a tendency to go down to the lowermost level of the mine excavation by seepage, by the process of seepage through the exposed rocks, particularly through the rock from the faces of the mines in case of open cast mining. In underground mines also, the shaft is the major source of seepage of water and draining the groundwater into the deeper portion where the mine working is going on. Similarly, when any fault plane is exposed inside the mine, particularly in coal belt, then because the fault plane is a slippage, it is a slip of the bed of rocks. So, there is a clear cut fissures formed inside that, and that fissure allows the seepage water to go down into the coal mines, also in metal mines even. So, these are the ways the ground level goes down in case of mining activity. Acid rains. Now, the gaseous air solutions, what are the things which are commonly available to form acid in water. Particularly when you do the mining, there are two kinds of gases. One is the CO2, CO2 available inside the mine, because in coal mines you must have heard the word spontaneous heating. So, that spontaneous heating gives rise to formation of more CO2, and when this CO2 is coming out through the strata, through the pores of the strata, it is causing, it is getting dissolved in water, and it is forming the H2CO3, H2O plus CO2, that forms H2CO3, that is carbonic acid. Similarly, when coal burns, there are ample amount of sulfur inside the coal. It is by virtue of its formation, because when the vegetation gets buried to form coal deposit, in long run, along with vegetations, there are so many vegetations which are rich in sulfur. For example, the garlic, it is very rich in sulfur. So, similarly, there are other sources in vegetations which are contributing to formation of coal, and coal is containing sulfur even as high as up to even 3%, which is not desirable, because when it is burning, the coal is burning, the SO2 gets emitted in contact with oxygen. Any oxygen available, it will be forming SO2, and that SO2 comes out along with CO2 and carbon monoxide even, and that SO2 is easily dissolved in water. It is easily soluble in water to form H2CO3, H2SO3, that is sulfurous acid. Now, when H2SO3 combines with another part of the oxygen, when oxygen is sufficiently available to this reaction, then it will be forming even sulfuric acid also, H2SO4 also. I will show you the reaction in next slides, please. So, causes of water pollution. From where the, as I have said about the water getting accumulated in the sumps area inside the mine, after dissolving so many solids which are soluble, or even if it is not dissolved fully, it will be forming the turbid water. If it is totally insoluble in water, the solids, then it will be forming the suspended particles floating in the turbulent water. So, these all are going to sump through pumping or through drainage system in the mines, whether it is open cast or it is the underground mining. Then another source is that, as I said, gaseous solutions, gases get dissolved. So, CO2 is very feebly soluble in water. It is hardly soluble in parts, maybe around 0.4%, 0.5% like that, not more than by volume or whatever. SO2 is sparingly soluble in water, and that is forming sulfuric acid ultimately. So, those all go to the sump and get collected. From there it is pumped out to the surface, and from there, as soon as it is pumped out on the surface, because water is not desirable in any of the mining areas, it will be not allowing the people to work, it will be covering the areas to and it will be obstructing the people to work. So, it is not desirable at all. So, it needs to be pumped out, whether it is open cast mining or whether underground mining. This water, when it is released outside on the surface, which is likely to go to the public field in the sense the natural streams, the rivers, the farmlands, then it is causing problem, and then we have to have a concern with the polluted water, and we have to prevent this polluted water from going to such sensitive fields as I mentioned just now. So, how does it go? See, rain wash, it is quite common, particularly in open cast mines or even underground mines. When the waste rocks are put outside on the surface, or even ores are put outside on the surface, like copper mines, chalcopyrite, when it is put outside on dumps. Pyrite means it is having sulfur content, and that sulfur content in one or other way, when it comes in contact with the O2 of the air, there will be a small very slow reaction to form SO2, that will be giving rise to formation of sulfuric acid in long run, which sulfuric acid, maybe it is very dilute because there is ample amount of water coming from from the sources. So, it will be forming diluted sulfuric acid, but it will form, and when it is sent to the farmlands, it will be extremely harmful to the crops. Similarly, when the water is having solid turbulent water in turbulent water and solid particles suspended, when it goes to the field with solid particles, it will be forming a layer on the natural soil, and that natural soil fertility will be getting buried, up to which the roots of the seedlings of the plants in the initial stage, particularly of crops sowed there, will be not reaching to that rich natural bed below the coated bed above, because of the solid particles got deposited on the surface due to such harmful turbid and the solid suspended particles containing water came to the field. So, rain wash is one source. Now, rain wash, apart from rain wash, there is something called the slime dam, where the ash washed out from the coal mines or the impurities from the iron ore mines or from the metal mines. These impurities may be in the form of silica, alumina, etc. When it is processed in the processing plant or the beneficiation plant, then that slurry, or we call it slurry, or we call it tailings also in other word. So, these tailings, when it goes to the dam should not get ruptured from any of the corners. It should have enough space to decant the water, and then the water layered on the top, which is as good as the fresh water because of decantation taken place, should go to outside. If it is not decanting the water properly, the dam, the polluted water will overflow without getting decanted, and that will be going to the paddy field. So, that is another source. So, dissolved chemicals also get flown along with rain wash. So, rain wash is another it is a major source from the dumps areas where the waste dumps are there. That material gets dissolved chemicals like any of the salt or any of the bicarbonates, even etc. Even sodium carbonates are soluble in water, potassium nitrates are soluble in water. So, if these things go from the dump areas during the rain, the water getting percolated through the dump area will be having all these kind of problems, the solid particles in that suspended, the chemicals dissolved in that, the chemicals, gaseous chemical as well as the solid chemicals both dissolved in that. It will be all going to the natural streams. This will be creating problems to the near inhabitants, the villagers, etc. See, here I am trying to show the chemical formulae for different gaseous solutions getting formed in mine water. As I said, CO, CO2, SO2, P2O5 also. P2O5 is very common in case of iron ore and in case of coal also. So, this phosphorus oxide, phosphorus pentaoxide, this also forms the phosphoric acid as shown in the reaction. As I have said, CO plus O2 forms CO2, and CO2 in turns getting dissolved very feebly in water will be forming carbonic acid H2CO3, SO2 from coal burning and pyrites of ore plus H2O from moisture or from the natural rain water, it forms H2SO3, sulfurous acid. After that, when H2SO3 combines with O2 further from air taken from the air, it will be forming sulfuric acid, and sulfuric acid is quite corrosive material, corrosive liquid. So we have to stop these formations. Then P2O5 plus H2O, this is also corrosive, H3PO4 phosphoric acid it is forming. Explosive blasting, this is causing the emission of carbon monoxide, carbon dioxide, sulfur dioxide and NOx. NOx, why I have written NOx? Because nitrogen has got 5 valencies. So this complex form is this entire valency formations like N2O, NO and NO2, these all formations are symbolized by NOx. X stands for 1, 2, 3, 4, 5, okay, plus H2O. So this is forming nitrous nitric acid. This is also highly corrosive material, as you know. So these are quite dangerous material. So these are causing the water pollutions. Effluents, chemicals, slurry, tailings, dirty, as I have said, tailings, slurry from the plant, unhygienic water, turbid water, slurry disposals from mineral processing plant, as I said. Lowering of level of groundwater is caused by excessive use of groundwater due to pumping for plant and camp needs, blockage of water source, aquifers. Actually what happens, there are so many aquifers in the hilly areas, and particularly on the foothills, on the foot of the hills. If the water logged areas are there in the upper part of the hill, and then there will be aquifers at the bottom of the hill where the foot of the hill is there. So that is called aquifers. Okay. So these aquifers get disturbed. What is aquifers? This is basically a fissure in the earth crust, which is allowing the water from upper level to come down to the lower level, and then it is coming out. Okay. But when blasting takes place, because of rock movements and vibration inside the earth, the aquifers get jammed and it will be no more active. These aquifers are the main contributors to the surface water as well as groundwater. So the levels go down because of these aquifers are getting jammed. See, construct garland drains around the mine, quarry, mineral dump, etc. These garland drains are made just a few meters away on the top of the mining face. From the crest of the bench, it will be few meters, say about 2 meters, 3 meters away, and there will be a drain. So whatever catchment areas are there on above that topmost crest of the bench, of the topmost bench in the mines, in surface mining, that will be that catchment water will be collected by the garland drains, and those garland drains are diverted to a small reservoir made where the treatment is done of the water, of the polluted water. And once the water is made free of all these problems, then only it is released from upper part of the pond made, for that is called treatment pond or treatment reservoir. So these garland drains are made all around the topmost part of the quarry. Similarly, in underground mines, actually these underground mines, the rule says that any opening to the mine, particularly the shaft, the incline, the adit, etc., should have at least the level higher than 1.5 meters, higher by 1.5 meters above the highest flood level. Highest flood level in that area over last 10 years at least, as recorded in last 10 years. But it is better to have the record taken for this mouth of the opening to the underground through the shaft, etc., on the surface. That level should be at least 1.5 meters higher than the highest flood level of the last 40 years record, most preferably. If it is not available, HFL is not available, highest flood level is not available for last 40 years, then at least for last 10 years. Then partial usage of rain wash on dump for plantation by constructing bench to drains. See, whatever benches are there in quarry, at the toe area we will be developing some drains, so that the catchment water gets arrested there only, and because of higher level it will be going to the lower level throughout the year by its gravity, force of gravity, and it will be fetching water on the to the plantation done on the lower levels. It works as a, when the ponds are made on the higher level, definitely it will be working, even if it is made artificially, then it is fetching water to the aquifers at the bottom, and aquifers will be active. Then next, construct water barriers and catchment drain. Actually, wherever barriers and dumps are there, we make wall barriers to arrest these kind of rain wash water, and to gradually release it to the drain system, and from drain to the pond, the purifying pond where the water will be treated, and then after treatment it will be released. Then next, the drain the water to a pond and store, I said, allow sedimentation, decantation, I said, already have explained this thing. Add flocculating agents to help sedimentation. Particularly what happens when the solids are not sedimenting down, then water is too turbid. That means it is having lot many fine particles suspended in this, which are lighter also than water. So these remain suspended inside the water. So to make it sedimented, we add coagulants, the coagulants or flocculants, whatever you call it, like alum. What for we add alum in water? This turbid water will be clarified. How? The alum, by its reaction, by its ionization rather, it goes on coating the each and every suspended particles in the water in turbid form, and those will be made heavier and it will be settling down. It will be bigger and heavier and settling down ultimately. So flocculant, even alum is one kind of flocculant. Add chemicals to neutralize the harmful elements like acid, or if it is acidic water, we have to go on testing these waters in lab and find the pH value of this. If the pH value is 1 to 6.5, it is acidic, 6.5 is neutral water, and after that 6.5, say 7, 8, 9, more it is increasing, its basicity is increasing. So we can test in the lab what is its pH value, and then accordingly we may decide if it is acidic water, if 1 to 6 is the pH value, in that case we will be passing the water through a column of chemical which will be alkaline or basic in nature, like sodium carbonate or potassium hydroxide, like that, or carbonate, etc. It will be passed through that and it will be made neutral. In case of basic water, if it is too alkaline, the value is nearing the 10 as per the pH value. So in that case we have to pass it through acidic substance, maybe the acidic solution or acidic substance, to make it reacted, and the water will be free of any alkaline dissolved material or the particles in that. Screen filter and release treated water to natural areas. Naturally we have to put the screens, etc., filter, etc. Centrifuge plant treatment optional. Actually there are centrifuge machines which are separating the pure water from the suspended particles. This is working on the theory of centrifugal force at very high RPM. The RPMs may be as high as even more than 2000 RPM. So release water after treatment, keep track of outgoing water by physical and chemical analysis. So these are the measures we have to take to neutralize water and before releasing to its natural sources. Acid mine drainage. As I was telling you that acidic water comes out by virtue of the sulfur in the mineral, or sulfur is in the form of pyrites and sulfur in coal, etc., it is almost in free form. The sulfur in coal is in free form almost, but when it is combining with water, it is forming the feeble sulfuric acid. Or sometimes there are cyanide containing chemicals inside the earth. The problem was occurred sometimes in Ghatshila of Jharkhand area, where the copper mines are there, or even Jadugoda area where the uranium mines are there in Jharkhand. So, in that area, but it was not mine problem, it was the general common area, it was much away from the mines, and there was cyanide chemical through the water, through the groundwater in the well. So, these kind of things may happen. So, we have to properly treat it and then use it potable. Potable means consumable basically for all purposes by the human beings. Acid mine drainage. So, acid mine drainage is an acidic water having pH of less than 5, that means 1 to 5 it is scales, and also containing iron, sulphate and other metals which are formed under natural conditions when hard rock mines containing pyrite are exposed to the atmosphere or oxidizing environments. In fact, pyrites are the sulphide ore. It is like zinc sulphide, ZNS, it is pyrite. Chalcopyrite is a copper sulphide combined with iron. CuSFe combinations are, chemical combinations are this. Okay. So, similarly, so this kind of water when it comes out from the mines, then it is called acid mine drainage. Also we stated outflow of acidic water from mining sites. Naturally occurring microbes can also increase AMD production by increasing the breakdown of sulphide pyrite minerals. If water is stored in particular pond without in particular pond or reservoir for longer period, then there are microbes, there are bacterias available. So, that will be eating away the pyrite to make the mineral to make the water acidic. In fact, these kind of bacteria are used for leaching of ore also, which we will be studying about in a special method of mining in different conditions. So, leaching of ore means the sulphide is eaten away, the sulphur part is eaten away, leaving behind the copper. So, that way enrichment of ore takes place without processing. This is natural processing. AMD continued. Apart from low pH, the effluents of AMD also have high specific conductivity electrically, because acidic water has got the high conductivity towards electricity. It is a good conductor of electricity. High concentration of aluminum and manganese. Manganese is again poisonous. As the treatment of AMD is expensive and inadequate, it is often left untreated. The water is left untreated, that means. Pyrite is one of the most important sulphides found in the west rock of mines. When exposed to water and oxygen, it can react to form sulfuric acid. The following oxidation and reduction reactions express the breakdown of pyrite that leads to AMD. Next, that reaction has been shown in the previous slide, so I am not repeating here. So, I am just going to the introduction of hydrogen ions can affect the acidity of stream. When evaluating the extent, when the water is becoming acidic, you understand very well that it releases the hydrogen on the hydrogen ion and the SO4 double minus on the top. So, these ions. So, these ions are causing problems. See, actually this has got, the sulfuric acid has got self ionizing characteristic. So, this creates problem in the naturally stored water, I mean to say ponds, etc. When it is there in the earth, it is causing so many problems to the microbes or the living animals in the water like fishes, etc. So, these are dangerous to the lives of aqua lives, you can say aqua creatures. So, these are dangerous to that. AMD depletes the buffering ability of water by neutralizing carbonate and bicarbonate ions to form carbonic acid. AMD depletes the buffering zone ability. Buffering zone means it is if somewhere we are giving the column of or the wall of this basic material like carbonates and hydroxides and oxides, we are putting somewhere, it will be eaten away very fast. Once exposed to AMD, the affect carbonate buffering system, that so that forms the buffer before going to the basic material columns or the walls are keeping the acidic water arrested and not allowing to go to the field directly. After treatment it will only go to the field. So these buffering zones are getting depleted very fast because of more acidity of the water. The buffering system is completely destroyed below a pH of 4.2. That means the buffering system pH, the pH should have been high, 7, 8, 9 etc. or even more, but it comes down to 4.2, where all carbonates and bicarbonates ions are converted to carbonic acid. The carbonic acid readily breaks down into water and carbon dioxide. Bright orange colored water and stained rocks are usually telltale signs of acid mine drainage. That means, this is the color of water when it is having acidity, because it is dissolving so many minerals. The orange color is caused by ferric oxide precipitating out of the water. The precipitate forms are as AMD becomes neutralized. The metal ions remain soluble at low pH. As the pH rises, see, the metals are dissolved in acidic water. It means that as the pH rises, the iron oxides and precipitates out. Iron oxide oxidizes and precipitates out. Depending on the conditions, the orange colored precipitates may form inside the mine or several mines of downstream because of these reasons. This is the pH scale, and the examples have been given on the right hand side, what material has got how much pH. The upper part is shown red, that means it is more acidic. The lower part has been shown blue, which is more alkaline, and the central part is shown green and white, where and black is the pure water area where pH is 7. Effects of AMD. The major effects of AMD are seen with respect to aquatic resources. I said you, aquatic means not much direct impact is seen on humans as long as they are not consuming the water resources, but it definitely affects the aquatic lives inside the water, in the where it goes, and the fishes and the amoeba and the other small creatures in water are getting killed because of this, and it is having adverse effect in the nature. Sources of AMD, as I have said, mine rock dumps, tailings, impounding, underground and open pit mine workings, pumped natural discharge, underground water, diffused seeps from replaced overburden in rehabilitated areas. That means, where the people are living, we have put overburden there it causes problem. Construction rock used in roads and dams etc. If these rocks are used in construction of roads and dams around the mines, these will be also forming the AMDs. Secondary sources, treatment of sludge ponds, rock cuts, concentrated load out stockpiles etc. Concentrated spills along roads of emergency ponds etc. Controlling AMD, the major ecological source that could be harmed through AMD is water. Hence, it is important to control the flow of water. Sites, better to control it. Diversion of surface water flowing towards the site of pollution. Prevention of groundwater infiltration into the pollution site. These are quite common things. Infiltration into the pollution site, that means we should not allow this water to infiltrate, that means go slowly inside the where the pollution site is likely to be there. Prevention of hydrological sensitive areas, it means that prevention of hydrological water seepage into the affected areas. Wherever the areas are affected, we should not allow hydrological waters. Controlled placement of acid generating waste. Whatever acid generating wastes are coming out of the mines, like pyrites and those kind of things, particularly the waste rock, it should be placed in such a area from where, using the higher areas, we will be putting it on the lower areas where from where the water will be not going to the streams if it is properly surrounded by the this barricading walls. AMD control, the most environmentally effective technique available for mitigating AMD are, mitigating means putting it down and down and down till it is neutralized, are internal neutralization method. Internal means artificial. The chemicals usually used by for AMD treatment includes limestone, hydrated lime, soda ash, caustic soda, ammonia, calcium peroxide, etc., kiln dust and fly ash, etc. This is the different negative impacts of AMD shown under the chemicals, physical and biological and ecological columns. This you can go through properly and understand the situation. These are the common language, in very common language, nothing big. AMD prevention, flooding, sealing underground mines where the AMD water is coming out, underwater storage of mine, tailings, etc., land based storage in sealed waste heaps. That means we have to make the heaps of the wastage, overburden material or any wasted waste rocks, we have to seal it with the help of barricades. Blending of minerals wastes, if we blend the mineral waste with non-acidic minerals, it will be, or the basic minerals like limestone, etc., or fly ash. Fly ashes are quite common to be used from thermal power plants. So, these are absorbing this water and keeping it localized instead of allowing it to flow. Total solidification of tailings, yes, you have to form the cakes of that and then it has to be reused, because tailings are said to be the minerals of the future, because there is small quantities there which is subgrade mineral called today, but tomorrow this may, when the scarcity of minerals will be there, it will be again reused. So, it has to be made prevented properly, and application of anionic surfactants. That means we have to use such a surfactant which is absorbing the ions formed because of H2 and SO4 ions. Micro capsulation coating, as I said, there are so many bacteria which are eating away the sulfides, and it is preventing the formation of AMD. This is the AMD process. The lime tank is there on the left hand side, there is a pump shown in between the lime and the influents. Influents means the dirty water, the water which is coming from the mines area, or the polluted water, you can say effluents, the polluted water that is getting added from the right side of the circular pump. After that is going to flocculation and aeration plants. Flocculation tank is there, there is a blade rectangular size. What is that? Equalization and aeration. What is equalization? Bringing to 7 pH value of the water. Then clarifier. Clarifier means whatever solids are there after flocculants adding, that needs settling there. These clarifiers are quite big tanks having the diameter of 20 meters, even from 10 to 20 meters, and this will be because of its depth and the vastness of the water content, it will be allowing the water to settle down. From there the decanted water is recycled for use, and the thickener effluents, thickener is at the bottom portion shown here. So, thickener is again it is collected water from the bottom layer. So, that is going to the purification circuit again, and recycled water is after that solid, then it is solid, this material is wasted, I mean to say it is thrown to the solid containing this one, the sludge is getting disposed of to the safe place from where the pond, that pond will be not allowing to go out any further sludge material outside to the public places. The alternative ways to mitigate is prevent, already these have been discussed, collect runoff seepage to contain acid localized, water dump slopes must be carpeted. Coir matting, what is coir matting? Coir matting is made of, it is a big sheets of coires. Coires means coires resins. Coires resins means you understand coconut, the peel of the coconut which is also used for making ropes. Similarly, the coires are made like your foot mats. Okay. Massive plantation, then actually the coir is having, I will show you the photograph. The coir is having the pores like your mats. So on the dump, first seedling is thrown, the seeds are thrown to grow. Above that the coir matting is done. In between the pores and holes, the new plant germinates and it takes a bigger shape. Till then the coir mats doesn't allow the water or any rain wash to go down profusely. So that way it is arrested. Retention walls with separate holes must be provided with proper drainage system all around. I will show you the diagram. See, this is the waste dump. Top on the top portion is shown, and the bottom portion of the waste dump has been covered with coir mats. Yeah, coir mats, and that one is preventing the rain wash of water abruptly to the down area, and whatever seepage is coming out through the dump is getting retained by the retention wall, and below the retention wall where the ground contact is there, there the small holes are provided which allows the slow seepage of water. Along the outer periphery of the retention wall, there is a drain made. That drains collects the seepage water from the dump which has come slowly down, and that will be directed towards the artificial ponds where flocculation, sedimentation, decantation, this all takes place, and decanted water is left to the surface, to the natural resources. Reasons of lowering water level, I have already discussed about this. Then there are some other additional things. Wetting of mines road for dust suppression. As I have said, because of the lower area in the excavated portions, the water rushes by gravity. So that is lowering the this one water level. Similarly, wetting of mine roads, so we do maximum pumping of water from the natural resources. So that is why it is lowering the area around. Processing of minerals, approximately 30 to 40 liters of water is consuming per ton of ore. So you can understand how much it is consuming daily. Sprinkling water for dust suppression at material transfer points on conveyor systems and loading and unloading plants. Then maintenance of and cleaning of machineries, etc. And we also give the residential areas water supply to the mines colonies, etc. So these are the mining activities which are causing the lowering of water, and then there will be problems in getting water for irrigation around in the paddy fields, etc., in the crop fields, etc., and villagers will be agitating. So these should be prevented the way it has been told in the previous slides. Prevention of water, treatment of effluent water, as it has been shown, if we are using the decanted water for recirculation, we can save 60 to 70% of water pumpings from the natural resources. Making ponds on upper areas, as I said, that will be keeping the aquifers and the ground level water up. Providing hand pumps at different locations for rural usage. Hand pump will be limiting the use of water. There will be no huge pumping of water, so that way it can be prevented, and the villagers will be also satisfied. Water harvesting with every individual residence and buildings used for mining purpose and colony. Thanks to all of you.